An archer shoots an arrow from a height of 5 feet at an angle of inclination of 30 degrees with a velocity of 30 feet per second. Write the parametric equations for the path of the projectile and sketch the graph of the parametric equations. Okay, so using these formulas, we would just plug in height of 5, so that goes in for h sub 0. Angle of 30, so that would go in for both of the thetas, cosine 30 and sine 30. What does that end up doing when you plug that in? So initial velocity, let's just look at one of them here. So initial velocity is 300, and then we do the cosine of 30 degrees times t, right? Well, we know the cosine of 30 degrees, so we could probably just simplify that right now, couldn't we? What's the cosine of 30 degrees? Do you remember? Square root of 3 over 2. Good. So 300 times the square root of 3 over 2 times t. So x is simply a linear location of its horizontal location is just a linear relationship. So we could simplify this further. X is 150 square root 3 times t. So depending on the time, that gives us its horizontal position. Does that make sense? So then you would do the same thing and use the other side to create the equation for the vertical position. Okay? Then it has you answer some questions. Oh, and you're supposed to graph those. So that would be like you did on earlier problems. So to graph them, you just plug in different values for t. And plot. You remember how we did on our examples last time? We did the beginning of 6.5. We did a table with t and x and y, and then we graphed the x's and y's, right? Or you could use your calculator to help you. Okay, 38. If the arrow of exercise 37 strikes a target at a height of 5 feet, then how far is the target from the archer? So the arrow started at a height of 5 feet with the archer, went up, and back down, and then struck a target at the same exact height. So we're trying to find how far the target is from the archer. That's horizontal distance, isn't it? So in order to do this problem, we would need to know how much time that is, because our equation is for t. So we need to know how much time it takes for the arrow to go from the archer to a vertical height of 5 feet again. So the only way to figure out the time t would be to take the vertical distance 5 and plug it into the vertical equation, which we didn't do here, the y. So you would plug in 5 into the equation that has y equals blah 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 and solve for t. And that would be a quadratic problem to solve, because you'll have t equals 0 because the arrow started at 5 feet, and then you'll have another t value where it reaches 5 feet again. Right? So there's two answers. It's a quadratic. So then whatever the t value is when it hits the target, right? Whatever that t value is when you find that using the y equation, then you plug that t value in here, and that will give you x value, which answers question 38, which you're not actually doing on your assignment. It's very sad. Okay, for how many seconds is the arrow of exercise 37 in flight? That would also require the y equation, because you would be saying how many seconds is it in flight. Again, that's kind of a weird order to put these questions in, because in my opinion, you need the answer to 39 in order to do problem 38, which is what we just talked about. So if it strikes a target at a height of 5 feet, then that's the answer when the y value is 5 feet. And the equation, I guess we should maybe go ahead and create the equation. Plus 300 times the sine of 30 times t plus the beginning height is 5. So now the ending height is at 5 and the starting height was at 5, and sine of 30 is 1/2. So we end up with negative 16t squared plus 150t. And since there's a 5 on both sides of the equation, doesn't that just cancel each other out? So can't we just say that this equals 0? And then how do you solve this quadratic? Factor out a t. So one of the answers is t equals 0. How do we find the answer we really want? Yeah, set this equal to 0. So subtract the 150 and divide by negative 16. It doesn't ask for a certain number, so just give me a couple, 1 or 2. 9.375. Okay, that sounds good. Alright, so time, 9.375. Time in flight, and then, so that's problem 39 that you actually are doing. I kind of want to make you do 38 and plug that into here and solve for x, so you see how horizontal distance it goes. And then, what is the maximum height reached? How would that answer be found? Maximum height reached by the arrow. Do you know how that answer would be found? It's the vertex of the parabola. Do you remember how to find a vertex? It's the maximum, the vertex of a parabola. Negative b over 2a. Does that sound familiar? Negative b over 2a. So you would take these, negative b, negative 150 divided by 2 times. So it's going to be half of this number, isn't it? Doesn't that make sense? If the arrow is flying for 9.375 seconds, that it's going to reach the maximum height at half that, right? Because it'll go half of that time going up from the archer at 5 feet, and half of the time going down to the target at 5 feet, because it'll be even between the two 5 feet marks, right? It doesn't. Nope. Gravity just makes it come back down. It doesn't change the initial speed. Really, okay, so the speed is not a constant 300 miles per hour through the problem. It's just that that's the starting speed. And so the speed slows down as gravity works on it, and then the speed speeds up as gravity works on it, so that when it comes back down, it would be going at the same speed it started at. Yeah. Okay, so this is going to be the middle. So the middle of the graph would be this divided by 2. So 9.375 divided by 2, what time would that be? Just give me the whole decimal. I know it's big and ugly. Okay, so that's where the maximum would happen, but we want to know the maximum. We don't want the time for the maximum. We want the actual maximum. So then we actually take this and plug it into our equation for t, there and there. And this time you want to make sure you add the 5 if you want the actual height, right? Because it started at 5 feet, so these numbers are just going to give you how much it went above that 5 feet. So then you have to add the 5 to get the actual height of it above the ground. And that would answer question 40, which you're also not doing. But I'm using this as an example, more or less, to help you see how these types of problems would be done. Does that make sense? Okay.